I'm so sad that we are having to switch to all to distance learning. I don't get to see you guys for the next 2 weeks. But hopefully you can continue to check back on Canvas and watch the videos I post and try to do the worksheets. I'll send out an email about how the class is going to run, but that's basically what we're going to have to do. I'll also have some office hours. You can come and ask me questions when you're really confused. We're going to cover lots of material in these 2 weeks, and you're going to have a test at the end of it or right when you get back, and so it's really important that you're paying attention while we're doing it. Because we're starting a new unit, nuclear chemistry. It's our new unit. And if you can kind of look at the word nuclear and think about what we might be talking about this unit. So if you look at the word nuclear, it kind of sounds like nucleus. So in this unit, we're going to be talking about the nucleus of the atom, which this is what the nucleus is if you forgot. The nucleus, and we're going to talk about what happens when this nucleus is unstable and how that can cause chemical reactions. And we're going to learn the different kinds, and we're going to learn how to stabilize our nucleus and things like that. So it's kind of exciting because we're not just counting things anymore. We're starting to learn why those things are important. So why protons, neutrons, and electrons are even important, and why knowing their number is even important. So the first part in this unit is called radioactive decay. And that's what we're going to talk about. And so if you don't have a piece of paper or your science notebook out, I would pause the video and go grab that, so that you can be taking notes while we're doing this, because this is going to be really important for your test to have this information. So, in radioactive decay, the first thing we're going to talk about is a radioactive nucleus. So, radioactive nucleus is an unstable nucleus that breaks apart spontaneously and can change the identity of the atom. So I'm going to write that definition down for you. You guys should as well. Alright, so I'm going to just highlight some of the key terms in here for you. If you would like to highlight or underline, that'd probably be good. So the first part is that we're talking about an unstable nucleus, and we're talking about it breaking apart, and we're talking about it changing the identity of our atom. So we're going to see that as we talk about certain chemical processes. And so first, let's talk about what an unstable nucleus is. What even does an unstable nucleus mean? And so hopefully you guys are able to figure out kind of the answer to that question by doing the simulation that is posted above this. And you're able to figure out that it has something to do with this proton and neutron ratio. If we have too many protons or too many neutrons compared to our proton or our neutron, then our nucleus can be unstable. Usually we like to have a 1 proton to about a 1.5 neutron ratio. It's a little bit different for each atom. That's usually what we want. If we start having 1 proton to every 5 neutrons, or 5 protons to every 1 neutron, our nucleus becomes unstable, and then we go through these things called radioactive decay. So let's kind of look at an unstable nucleus right now. So here what we have is we have a bucket of polonium, and what we're going to do is it's unstable right now. And you're going to see when I pull one out of the bucket that it's going to shake a little bit, and then a particle is going to fly out of it. Alright, so when it's shaking, that means it's unstable, and then it will stop shaking when it's not stable, or when it's stable again. So here we are, it's shaking, it's not very stable right now. And then, in a little bit, it's going to undergo radioactive decay to become stable. So remember, this nucleus right now is having too many neutrons to proton. The ratio is off. So there we go. You see how now it's not it's stable now? It's not shaking anymore. So I'm going to show you with a bunch of them. If you also look, they start off as PO, and after that particle flies off, it's PB. So we can see that this element is actually changing, right? It undergoes radioactive decay, and it changes. Alright, so let's go back to our notes. So that kind of is talking about a radioactive nucleus and it's breaking apart and changing its identity. So next we're going to talk about some radioactive properties. And again, I would write this down as I'm writing it down. So we're going to talk about 3 radioactive properties. The first radioactive property is it can damage living cells. So this is why they have to label radioactive material. It's usually this like yellow triangle thing with these black lines. You could go and look at it online if you just Google like radioactive symbol or something like that. It will pop up with it and you'll be able to recognize it. But it can really damage our living cells as it undergoes these processes. And so it's important for us to be aware of what radioactive material is and be careful. The next thing is that it can cause certain compounds to be fluorescent. So, So you've probably seen this on movies or things like that when it's talking about radioactive material, it's usually glowing. Well, that's not true for everything. For most things that does happen, we do see some type of fluorescence around these compounds, and so that's pretty cool that that is actually a real thing. It's not just in the movies. And the third thing that we're going to talk about is that it can create an electric charge around the element. Alright, so that's kind of our intro to radioactive decay. Next we're going to talk about different types of decay. So like how we saw when that atom was shaking when I was doing the simulation and then a particle flew out of it, we're going to talk about the different kinds of particles that can fly out of it and how it can stabilize it. Alright, so we'll look for the next videos. There's going to be 3 other short videos that are going to talk about each kind of decay and the information that you need to know for your upcoming test. Continue to just click on the next one, watch it, take a little break if you need to, but make sure you understand this material and then try to do the worksheet. Alright, I'll see you guys in the next video.